All right, so now we're going to talk about two last vocabulary words. It's ground versus excited state. Okay, so ground state is everything that we talked about before, where everything looks normal. It's like standard electron configuration. So for example, lithium has 3 electrons. So you put 2 in the first house, in the first orbital, and then 1 in the 2s orbital. So it's filled nice. Everything looks normal. But now what we're going to introduce is this excited state. This excited state is when we add energy to it and it like gets the electrons all excited, like literally excited. So they like jump energy levels temporarily before they come back down. So like what it could look like is that you have 1 electron here, and instead of this electron, because normally it's like a down arrow here, it's going to like jump to a higher level. It could jump all the way up here, right? So do you see the difference between the one on the left and the one on the right? Okay, left is normal, right is when electrons like all of a sudden jumped up. Now eventually, like you can't be excited forever, it's gonna come back down to ground state, but it's gonna temporarily look wrong. So it looks incorrect, but it's just a temporary state, and then it comes back to ground state. So your goal is to be able to recognize if they are in excited or ground state. So I'm gonna do a few examples and then have you like practice and do the rest on your own. So here we go. You look at this first example, letter A here, and you're gonna be like, okay, is everything filled right? Or is it possibly excited state? So you're like, okay, 1s2, 2s1, 2p3. And all of a sudden you're like, whoa, wait a second. That's a little weird. An s orbital, an s house, right? The tiny house can fit 2 electrons in it, but right now there's only 1, okay? And they moved on to the 2p. So you're like, oh, probably excited state. One of the electrons probably temporarily jump to a higher energy level and eventually it'll swing back down, okay? So another example, letter B. Here's 1s2, 2s2, 2p6, and you're like, is everything filled right? Yep, everything is filled right. So then this we would call this the ground state because everything's filled normally. 2 electrons in the s orbitals, s houses, and 6 electrons in the p orbital or p house, right? So some other examples. So let's look at this one right here. Okay, it wants to know the element as well as if it's ground or excited state. So the first thing I'm going to do is I'm just going to count the superscripts to know what element it is. So I'm going to be like 2, 2, 5 is a total of 9 electrons. So according to my periodic table here, 9 electrons is fluorine. So I'm just going to write F for fluorine for short. And I'm going to check, does everything look right? 1s2, 2s2, 2p5. Everything seems filled correctly. So ground state it is, okay? So let's look at the next one, okay? Here we have 1s2, 2s2, 6, 1, and 5. So I'm gonna count, that's 10, 11, 16. I think this is 16 electrons. So according to my periodic table, 16 right there is sulfur. So I'm just gonna write sulfur, boom, right here, okay? So then I ask myself, okay, is anything weird or is it all normal? So I'm gonna look 1s2, 2s2, 2p6. What is this? This 3s. This 3s should have 2 before moving on to the next house, the next orbital. So this must be temporarily in the excited state. Okay, so I'm gonna let you pause for a second to see if you can do more practice on your own, and then I'm just gonna reveal the answers. All right, so here are all the other answers in case you needed it. Number 3 was a little tricky. So one of them is completely wrong because it breaks too many rules. Even if you are drawing something in the excited state, it still needs to follow like the Pauli exclusion rule and the Hund's rule about like 1 in each room, and it has to have opposite spins. Like you have to follow those rules. Letter B is excited, like everything's filled in normally, except it's missing that down arrow. So it probably temporarily jumped to a higher level, to a bigger house, and then it's going to fall back down eventually. Okay, so let me just show you how that looks in a Bohr model. Okay, so here in a Bohr model, okay, so lithium has 3 electrons, right? So 3 electrons are just hanging out, doing its own thing. Okay, now if I add energy to our lithium, okay, and you're gonna eventually see this in the lab, then it excites the electrons, and the electrons can like start jumping and going crazy. So I'm gonna show an example of just one electron jumping. So here we Okay, so here we can see that one of the electrons are going to jump up to a higher level, okay? So it leaves its house temporarily to move to a different house, but you cannot see this, okay? So trying to make this really clear here, you cannot see this happening. You cannot see electrons get excited. It happens. But what you can see is when it decides to come back home. So when it comes back home, okay, it's gonna have like a certain effect. So gaining energy is something they got from the fire, for example. So remember this electron here now needs to come back home. So it has to return to ground state. So when it decides to come back home this way, it doesn't go here anymore. Now it's back to its original spot. So if it temporarily gained energy, what does it need to do to come back home? It needs to lose energy, right? So when you lose energy, okay, sometimes you lose energy in the form of a beautiful color. A color, because remember, every color you see is filled with energy. Okay, I know that boggles your mind that you see like a color over here, you see me, I'm in color, then I'm exuding energy, okay? And so what happens is when it comes back to ground state, it sometimes releases a very beautiful color that you can see with your eyes, okay? It sometimes releases energies that we can't see, but we picked certain like elements where you can see those colors, and it's like very beautiful, okay? But for every light that you see, every color that you see, that is a form of energy. So when it does return down to ground state, you're gonna see that release of energy. So you see the release of energy, right? In the form of color. So that's what it says right here. Okay, energy is released in the form of light. And hopefully you'll get to see this in your flame test lab. All right, sounds good.